transmissibility, coplanar and concurrent force system, what is the resolution, and what are the various conditions of equilibrium. So let us start with the principle of transmissibility. According to this, any other point, keeping the line of action same, the external effect of the force on the body will remain unchanged. Right? So let us consider this figure A. Here we have a body. Okay. A figure को देखिए. We are applying a force F1. Okay. In the second figure, we place one more force parallel to the first force, but in the opposite direction, keeping the line of action same. Right? My cursor is visible. My pointer is visible to you?
No, sir.
No, sir.
It is not visible. Just a moment. देखिए यहाँ पे क्या है, हमारे पास दो फोर्सेस हैं. ये F1 तो हमने as it is रहने दिया. And on the same line of action, we apply two more forces of same magnitude but opposite direction. So here, in the upward direction, we have force F1, and in the downward direction, we have force F1. Okay, so we add these two forces, but in the opposite direction, right? Now, as this force and the force at the bottom, which are cut by a black line, दिख रहा है आपको ये black line?
Yes, sir.
इन दोनों forces को हम cancel कर सकते हैं because they are acting in the opposite direction. Okay, so we are left only with the upward force. So in the third figure, we have only F1 force, and if such an shifting is made, so net effect on the body will remain unchanged. Net effect on the body will be zero by adding this force. If we shift this force to this position, the net effect on the body will remain unchanged. Right? Suppose करिए अगर कोई फोर्स लगाने के बाद बॉडी में एक्सीलरेशन 5 मीटर पर सेकंड स्क्वायर का जनरेट हो रहा था, then if we shift this force to another point with keeping the line of action same acceleration will be produced by the in second case also. Then the force is shifted to other point. Getting my point? Is it clear?
सर सी वाला एक बार दोबारा बताना.
मैंने आपसे क्या कहा कि अगर फोर्स F1 जो प्रिंसिपल ऑफ ट्रांसमिसिबिलिटी है, प्रिंसिपल ऑफ ट्रांसमिसिबिलिटी क्या बोलता है कि अगर किसी पॉइंट पे फोर्स लग रहा है और उसका लाइन ऑफ एक्शन हम सेम रखते और पॉइंट ऑफ एप्लीकेशन चेंज कर देते, सपोज इस पॉइंट से हमने इस पॉइंट पे ये लगाना शुरू कर दिया, कीपिंग द लाइन ऑफ एक्शन सेम, ओके, देन द एक्सटर्नल इफेक्ट ऑफ द फोर्स विल रिमेन अनचेंज्ड. जो पहले एक्सटर्नल इफेक्ट था फोर्स का वही अभी भी रहेगा. सपोज करिए कि पहली कंडीशन में अगर हमारे पास जो एक्सेलरेशन मिल रहा था बॉडी में, सपोज दिस फोर्स विल प्रोड्यूस एन एक्सेलरेशन ऑफ 10 मीटर पर सेकंड स्क्वायर. ओके, and in the third case also or in the second case also we have the same acceleration. Same acceleration क्यों होगा second case में? Because F1 and F2 force are balancing each other and will cut each other. The net effect of these two forces is zero, right? In the third case also we are only left with the one force, so acceleration is again 10 meter per second square. So this is basically principle of transmissibility. Now it is clear?
Yes, sir.
Okay. So coplanar and concurrent force system. Coplanar जैसा कि नाम से ही पता लग रहा है आपको, with the forces which are lying on the same plane are termed as coplanar forces, and the forces passing through the same point are known as concurrent force system. Okay, if all the forces are passing through the same point, then those forces are termed as concurrent forces. Clear?
Yes.
जैसा आप यहाँ पे देख रहे हैं कि ये तीनों फोर्सेस किसी एक ब्लॉक के ऊपर एक्ट कर रहे हैं, एंड इफ all the forces are passing through the same point, then this system of forces is known as concurrent force system. Okay? Now, what is resolution of force? Resolution means तोड़ना. अगर हम सिंपल भाषा में बात करें, resolution means तोड़ना, and resultant means जोड़ना. So basically we have a force here. ठीक है, यहाँ पे हमारे पास एक फोर्स है F, इसके दो कंपोनेंट्स हमें x और y डायरेक्शन में हम इसके कंपोनेंट करना चाहते हैं. देन व्हाट वी विल डू, सपोज करिए हमारे पास ये एक फोर्स था F एंड वी वांट इट्स कंपोनेंट इन x एंड y डायरेक्शन. सपोज दिस इज x, दिस इज y. ठीक है, इन दो डायरेक्शन में हम इसके कंपोनेंट निकालना चाहते हैं. कंपोनेंट का मतलब क्या है? इफ दिस फोर्स इज रिप्लेस्ड बाय इट्स कंपोनेंट, the same effect will be produced. जो इस फोर्स के द्वारा इफेक्ट मिल रहा था हमें, सेम इफेक्ट जो है अभी भी मिलना चाहिए. Then that type of system is known as resolution of forces. Right? तो यहाँ पे देखिए इसके कंपोनेंट हम कैसे कर सकते हैं. We just drop a perpendicular from this point to x-axis and we drop a perpendicular from this point to y-axis. Okay? So what you will see, now this is a right angle triangle and if this angle is theta, ये एंगल आपको दिख रहा है यहाँ पे, ये वाला एंगल.
Yes.
This angle is theta. So perpendicular की वैल्यू क्या होगी आपकी? Suppose this perpendicular component is termed as Fy. So this Fy is what? बता सकता है कोई? Sin theta. Sin theta is what? Sin theta is perpendicular over hypotenuse. So perpendicular here is Fy and hypotenuse is F. So this is Fy by F. So from here Fy is F sin theta, right? So Fy component is F sin theta. Similarly, we can find out the x component also, that is F cos theta, right? और in vector terms अगर हमें इसको राइट करना है तो हम कैसे लिख सकते हैं? This is F cos theta, which is the x component and I is the unit vector in the direction of x. So F cos I cap plus F sin theta j cap. J is the unit vector in y direction and F sin theta is its magnitude in y direction. Okay?
Yes, sir.
We can express force as a in terms of its I and j component. So x component जो है, that is F cos theta. So it comes with the I cap, which is the unit vector in the direction of x, and y component is F sin theta. So it comes with the j cap. Okay, just a moment please. Can be expressed as F cos I plus F sin j, right? Is it clear?
Yes, sir.
So this is known as resolution of force. Now what are the conditions of equilibrium? Any body will remain in equilibrium if and only if sigma fx is 0, sigma fy is 0 and sigma m is also 0. What does it indicate? That in general terms, if we have to write the equations of equilibrium, then we have summation of all the forces must be equals to 0 and summation of all the movement must be equals to 0. Okay, then only the body will remain in equilibrium. तो पहली अगर इक्वेशन आप देखते हैं जहां पे लिखा हुआ सिग्मा fx एंड सिग्मा fy is 0, what does it represent? It represents that the body is in 2D. ठीक है, if the body is in 3D, we have one more component, that is sigma fz is equals to 0, right? Is it clear?
Yes, sir.
Okay. So let's see what is moment of a force. What is the physical significance of a moment? Can anybody of you tell me? A body, right? So let's see.
Okay, sir.
Moment is basically the vector product of r into f. R is the position vector and f is the force vector. R is the position vector of the point of application of the force. Suppose इस particular point पे, this is the body and इस body में इस particular point पे ये force act कर रहा है. Suppose R is the position vector of this point with reference to the origin, then moment is given as R cross F. Okay, it is the vector product of R and F. So to determine its direction, you have to use the right hand screw rule, or you just simply rotate this body by applying this force, then you will get the direction of rotation. So अगर आप इसको देखते हैं, अगर इस तरह की बॉडी पे आप यहाँ पे फोर्स लगा रहे होंगे, then you will see that it will rotate in a clockwise direction. Okay, so moment is again a vector quantity. It is having magnitude as well as direction. And in scalar terms, it can be defined as the perpendicular distance into force. So force into perpendicular distance from the point about which you are going to find out the moment. Okay. So suppose R is the position vector and it is given by Rxi plus Ryj plus Rzk, and F is the force vector and it is given by Fxi Fyj plus Fzk, then moment vector is given by this, which is simply the formula of the cross product. जैसा आप लोगों ने वेक्टर मैकेनिक्स में पढ़ रखा होगा या वेक्टर अलजेब्रा पे आपने शायद मैथ्स में पढ़ा हुआ हो, ये m is equals to ijk, determinant of ijk, rx, ry, rz and fx, fy, fz. Okay, is it clear?
Okay.
Next, principle of moment, or it can be also called as Varignon's theorem, right? Varignon's theorem क्या बोलती है हमें कि summation of movement of individual forces is equals to the movement of its resultant about the same point. So suppose F1 and F2 are the two forces and the resultant of these forces R, and we want to find out the movement of these forces about this point, say, then R into D, R is this one, D is this distance, which I mark with the black color. So force into perpendicular distance, RD, is equals to summation of movement of its component about the same point. Okay, so if you calculate, this is the point O about which we want to find out the moment and its perpendicular distance. यहाँ से मैंने इसको थोड़ा दूर दिखाया हुआ बिकॉज यहाँ पे स्पेस की प्रॉब्लम थी. सो दिस इज बेसिकली डी. तो इस पर्टिकुलर पॉइंट पर अगर देखते हैं तो F1 इंटू D1 प्लस F2 इंटू D2, दिस इज द अलजेब्राइक समेशन. तो अगर यहाँ पे आप देखते हैं तो यहाँ पे माइनस साइन आना चाहिए था बिकॉज F1 इज इन द क्लॉकवाइज डायरेक्शन एंड F2 इज इन एंटी क्लॉकवाइज डायरेक्शन. ओके, बट यहाँ पे हमें केवल फॉर्मूला दिखाना था, इसकी हम डायरेक्शन चेंज कर देते हैं, देन इट बिकम्स ओके. Suppose F2 is acting in this direction, then both the force will give you clockwise movement. So F1D plus F2D is equals to resultant into D. This is Varignon's theorem, according to which the movement, the summation of movement of individual forces is equals to the movement of its resultant about the same point. Okay, is it clear?
Yes, sir.
Then we have Lami's theorem. यहाँ पे मैंने statements नहीं लिखे हुए हैं, ठीक है? अगर if you have any doubts, please ask. Lami's theorem क्या बोलती है? If a body is in equilibrium under the action of three forces, अगर कोई body equilibrium में है under the action of three forces, then each force is proportional to the sine of the angle between the other two forces. Okay, each force is proportional to sine of the angle between the other two forces. So here, suppose the body is in equilibrium under the action of F1, F2 and F3, then F1 force is proportional to sine of the angle between the other two forces. So angle between the other two forces is beta. So F1 is directly proportional to sine of beta. Right? Similarly, F2 is proportional to sine of gamma. Right? And F3 is proportional to sine of alpha. If a body is in equilibrium under the action of three forces, then each force is proportional to sine of the angle between the other two forces. This is the statement that is given by the Lamis. Okay. So you just look at this equation. F1 over sine beta, अगर हम इसको इधर ले लेते हैं, then if k is the constant of proportionality, then आप इनको तीनों को equate कर सकते हो. F1 over sine beta is equals to F2 over sine gamma is equals to F3 over sine alpha. Right? Okay. Lamis theorem clear हुआ आपको?
Yes, sir.
Then we have couple. Couple आप लोग जानते हैं, if two forces are separated by two equal and opposite forces are separated by a certain distance, then they will form a couple. Okay, couple की खासियत क्या है कि it will not give you any translational motion, it will only produce the rotational motion. Translational क्यों नहीं मिलेगा? Because these two forces are equal and opposite to each other, so they will cancel out each other. But they will form a couple at the same time. Suppose these are the two forces which are acting on this body. Okay, so this is suppose the center, or you can find out the movement about any point, and the force and the gap between the two forces is suppose d, and g से इसकी distance suppose d1 है perpendicular distance, और यहाँ से suppose d2 है इसकी distance f2 force की इस point से, then g point के अबाउट ये क्या है, एक clockwise movement फॉर्म कर रहा होगा जिसका मैग्नीट्यूड कितना होगा, f इंटू f1 इंटू d1. ठीक है. सिमिलरली जो f2 फोर्स है, इट विल अगेन फॉर्म ए कपल इन द क्लॉकवाइज डायरेक्शन. इसका मैग्नीट्यूड कितना होगा, क्लॉकवाइज है इसलिए दोनों सेम हो जाएंगे, इसलिए सेम डायरेक्शन में इसलिए ऐड होंगे. तो नेट मूवमेंट इज f1 d1 प्लस f2 d2. ओके, as f1 is equals to f2, so we can just write it as f d1 plus d2, and d1 plus d2 is nothing but fd. So the magnitude of couple you can directly write as f into distance between the two forces. Okay, is it okay?
Yes, sir. Yes, sir.
नेक्स्ट जो सबसे इंपॉर्टेंट चीज है दैट इज फ्री बॉडी डायग्राम। सुना है आपने इसके बारे में पहले? 12th में आपने शायद फिजिक्स में सुना होगा।
यस सर। यस सर।
जानते हैं फ्री बॉडी क्या होता है, बताइए। If the body under consideration is freed from all the contact surfaces and all the forces along with the reaction and weight are shown on the body, then that diagram is known as free body diagram. Okay. Suppose यहाँ पे एक inclined plane है जिसके ऊपर ये एक weight रखा हुआ था W magnitude का. Okay. So what are the different forces which are acting on this body? If we will make it free from all the other contact surfaces, कहाँ से contact में है ये? इस point पे contact में है. तो यहाँ से अगर हम इसके contact को remove कर देते हैं तो यहाँ पे ये बॉडी क्या कर रही होगी, इसके ऊपर कुछ फोर्स अप्लाई कर रही होगी, कुछ प्रेशर से जो है इस रैम को दबा रही होगी, राइट। इन रिस्पॉन्स ये इंक्लाइन प्लेन क्या करेगा, इसके ऊपर कुछ रिएक्शन फोर्स लगा रहा होगा अकॉर्डिंग टू न्यूटन्स थर्ड लॉ ऑफ मोशन। तो इसके ऊपर जो फोर्स लगेगा वो अपवर्ड डायरेक्शन में लग रहा होगा। सो दिस इज द रिएक्शन फोर्स, यू हैव टू शो द रिएक्शन फोर्स। सपोज दिस इज एन। नाउ इस पे इसका वजन एक्ट कर रहा होगा, दैट इज डब्ल्यू। ठीक है, ये बॉडी नीचे स्लाइड करने की कोशिश करेगी तो इस पे एक फ्रिक्शन फोर्स भी लग रहा होगा। सपोज दैट फ्रिक्शन फोर्स इज एफ आर, सो दैट इज आल्सो शोन ऑन द कॉन्टैक्ट सरफेस। फ्रिक्शन फोर्स हमेशा दोनों सरफेस के इंटरफेस पे लगता है, तो ये निचली बाउंड्री पे नीचे वाली साइड में ये एक्ट करेगा। इफ ऑल दीज फोर्सेस आर शोन on a body, then this body is known as, or this diagram is known as free body diagram of this block, right? What you have to do, you have to make the body free from all the other connecting surfaces or contact surfaces, and you have to show all the forces that are acting on the body along with weight and reaction forces. Is it clear? Then that diagram is known as free body diagram. If you are able to draw the free body diagram, then 50% of the mechanics is solved. ठीक है, अगर आपको फ्री बॉडी डायग्राम ठीक से बनाना आ गया, then आपने आधी मैकेनिक्स जो है कंप्लीट कर ली, आधी जंग आपने जीत ली। ओके, यहां तक आप लोगों को किसी को कोई डाउट है तो बोलिए।